Hello world, this is Craig. Well, a toggle switch on my Altair 8800B broke off, so I decided it's high time to recap the unit while I'm repairing the toggle switch. It's a simple linear supply. The transformer has two secondaries, one for the 8 volts and one for the plus and minus 18. There's a bridge rectifier on the back panel for the 8 volts, and then down at the bottom there's a power supply board that's got a bridge rectifier for the plus and minus 18. And the plus and minus 18 have pass transistors and then filter capacitors in the back. There's a filter capacitor for the 8 volt. Here you can see the filter capacitors for the plus 18 and the minus 18 a little bit better there. And without a load, our voltages were spot on. So with a 1 amp load, 17.5 minus 17 and 0.4. So they've drooped a little bit with the load, but not bad at all. We have 8 volts, but of course we don't have a load on the 8 volts right now. Okay, so with a load, let's see what our temperature on our capacitors are, filter capacitors. This is the plus 18. And of course the reason we're checking these, we want to make sure that we don't have a hot capacitor that's going to fail and then possibly blow out somebody downstream. 17 degrees, 16 degrees. Okay, the inside chassis just slides out of the outside blue part. The only thing holding it in are a couple of socket head cap screws on each side that hold this aluminum bar on. I'm not sure this is the same on everyone's Altair, if that's just the way that mine works, but we take out the cap screws, take off the bar stock. Okay, then with the screws out, the inside just slides out. It's a whole unit with the front panel on it. And then we can just lift it up and take out the outside frame. And then the front panel with the display on it, or the plastic, just lifts over the switches carefully. Okay. And that's it. There's the classic Altair 8800B front panel. Quite a piece of work. Okay, let me set that over here. Okay. You can see it's an 8800B with the flat paddle switches. There's the one that broke off. All of the on-off ones feel okay. Maybe the momentary one, the single step, this one here, he's loose. Yep. It's going to be a sad day when he breaks because I don't have any more of the momentary ones. I have to make him from scratch. Yep. Okay, I'm not too proud to label these things. Particularly don't want to get the transformer mixed up. This is the 18 volt. Get the center tap and the two windings on the plus and minus 18. Okay, this is the ground. He's strapped to the one next door, and that takes the center tap of the plus and minus 18 to ground. And some of these are all strapped together. Okay, the plus 18 is connected to the pass transistor. Now some of these, like the ground and the two from the transformer, actually go through the board, and they're connected on the other side with nuts. So there's nuts on this side, and the other side is where the transformer is connected. So they reach across. These have nuts, and so you want to make sure that you don't unscrew any of those, or the nut will fall off in the back. So unless you got to take it apart, don't take any of those screws out. Okay, and the back just comes off and pulls away. So there's the PC board, the power supply board. You can see the nuts on the back I talked about. So that's why the transformer's there. Okay, these little ears, this circuit board, are bit flimsy, so I'm putting heat right on the lead of the capacitor. This guy doesn't want to come out. Remelt him a little bit on the back. Ooh, you can see how flimsy that edge is. But I don't want to put too much heat on this. Fortunately, there aren't any traces on the top, so we're not quite so worried about lifting the trace up. But I want to keep my heat concentrated right on the lead and pull these out. So you can see the 2200 microfarad, 25 volt. So those two are for the plus 18, these two for the minus 18. Okay, well, I'll come back when I got these out in case this is going to fight me and make me look like an idiot. Okay, we'll come back. Okay, now the capacitors are out, so reflux them and put on the solder wick, a wide tip. See if we can get all the solder out and get a nice clear hole so we can put the new capacitors back in. Not stress this board any more than we already have. Okay, it's coming out pretty good. Okay, the new caps. Just slide in if the holes are clear. You can tell they're quite a bit smaller than the old ones. This board would have been nicer if they hadn't put these gaps in for the caps and just set it on the top, but I guess they were pressed for room. Okay, make sure we don't put it in backwards and it's the right value. Negative. Negative. Yeah, do not want to put one of these in backwards. Only take an instant to destroy it. Try to get them back in centered. Make them look nice. Okay. It's just a matter of getting everything straight here. Nicely seated, centered. Get my leads where I like them. And then we're going to solder them on. Okay. I put my narrow tip back on. Get the pad and the lead warm. Put the solder on. Make sure that it's a nice, bright, shiny solder. I'm not going to be too shy about putting solder on here. Oh, my tip got cold for some reason. Okay, well, solder and solder, and you don't need to watch me do all of this, so I'll solder while you go do something else, and we shall return. Okay, we're back, all soldered. I'm going to clip off these leads and make sure I know exactly where they go. I don't want these flying into my bus. So grab a hold of them, don't just snip them off and let them fly. Okay, we are done. Recapped, ready for another 30 years. Now you don't have to clean the flux off, but only takes a minute, so I just use alcohol and a Q-tip or a chem wipe and just soften it up, and the flux comes off pretty easy. Just makes it look a little bit neater. There's no reason to leave it on. Next person will think bad of me if I leave flux on. Okay, so we just clean all these off. Okay, final check. Everything looks good. Straight. Check the arrow, the polarity. Yep, we're okay there. Okay. There's the pass transistors, plus and minus. And then the Zener diode for the minus, the plus. 18 volt Zener. Okay, we're ready to go back together. There's a ground strap there that you couldn't see before. Just remount the PC board, the power supply board, and everything else will go back in the back panel the way it came out. Reconnect the terminals. So there isn't anything exciting. Just make sure that we don't get anything pinched. So I'm just going to fast forward past all of this, and it's simple enough. Okay, so the caps in the power supply have been replaced. It's been tested. So now it's time to look at this broken switch. There's only 4 screws and the power connector and a ground that hold this together. So now we just take out these, take the nuts off the switches. Only the ones that have the little recess have a nut on them. So just a 5/16 deep socket. Take these off, and then the board will come off the back. I'll fast forward through the rest of this. It's not very interesting. Okay, so here's the display board, front panel with the switches. So now let's get this broken switch out. Well, there's 2 good ways to get this component out. One is to use the hot air rework, like what I'm doing here. The other is to just take the soldering iron and put on a nice big glob of solder that covers all 3 pads. And I was torn which way to go. Right about now I'm starting to think that maybe the big glob was the better way, because I'm putting quite a bit of heat on this switch. But the switch is taking it, the silkscreen solder, or the solder mask is taking it. So far I'm not worried. But just keep the solder iron or the hot air moving, and pretty soon you start to see the solder glisten, and we're getting close. Solder will start to glisten, turn bright. You can see it start to turn there, and then it'll just loosen up and the switch will pop out. There we go. Okay, I let that cool for a minute. I'm going to put some flux on it, help the solder wick suck up the solder. The flux pin's a little dry. It's a pretty beefy solder wick. Find a clean spot here. And hopefully I can suck it all the way through. There's not a lot of solder on the other side. I'm hoping I can suck it and get the hole clear. If I can't get the hole clear, then I'll put some fresh solder on it and try wicking it back out. I don't have a pump to blow the solder out or suck it up. No, it's doing pretty good. It's coming out. Yeah, that's looking pretty clear. I think I'll be able to get the switch back in those if I just clean up the other side. Okay, I got the new switch in, and I'm just going to hold it up with my pinky here, and then just put solder on this one pin, kind of tack it. I don't want it to be in there really hard in case I have to remove it again for some reason. So I just want enough to hold it, and then I'm going to flip it over and let's take a look at it. Okay. That's right. Works. It's in line. The height is the same as everybody else. It's straight. Okay. It has to be the same height. Make sure it doesn't stick too far out the back of the panel. Everything looks okay. Alright, so I'm going to go ahead and solder the other two pins. And call it done. There's another switch. The A0 has been bugging me. We'll see after I finish this to see if I want to replace that A0 switch too. Okay, this is A0. He just doesn't feel right. I have plenty of switches, so I think I will go ahead and replace him. Okay, well, same process, so I'll be back when it's done. Okay, switch is done, all checked out. Now let's put this front panel on. Just kind of angle it, start at one side, and gradually just tease it forward so the switches on one side are in, and then as we need to, just pull the switches. The momentary ones are, of course, they're in the center. Then just one by one, gently tease it. Don't want to break a switch. Try not to put too much pressure on anybody. And almost done. And there she goes. Okay, so we get everybody down, get the holes through, and the two new switches look good. Okay, so now let's put the nuts on. We're going to put the nuts. Okay, well, we put the nuts on, and I'll be back when the nuts are all done. Okay, so the front panel is screwed back on, and with the switches we just do the same thing we did before, only it's a little bit tougher because we can't quite get in there very easily. So I have all the address switches up, and I just one by one push them down and tease them into the hole, hold the front panel at a little bit of an angle so the ones that are already flipped get stuck in their little hole, And the ones that haven't been flipped have enough room. And just carefully tease them on in. Okay. All right. Well, the front panel's on. So now this just slides back into the chassis. The outer chassis. Like this. Okay. And then we just put the screws back in the side. And we're done. Okay, well, I'll come back when we're all done. Okay, everything's back together. We're powered up. Just going to check the voltages one more time. Put it ground. It's my +8. It's good. My +18. My -18. Okay, everything looks good. So that's it. Thanks for watching. There's some Altair videos on YouTube, but not very often do we get to see the inside of them and how they work. So I appreciate it. I hope it was interesting for you. And if you find an Altair at a garage sale or something, make sure you rescue it. They're an important piece of history. Okay, thanks.